viewers, welcome again. This is Mr. Dingo, and I want us to be able to complete this chapter of series and sequence. We have two areas, the recurrence relations and also modeling with series. Now, you understand that sometimes we may not have a sequence that is flowing smoothly like the ones we have seen before. That is geometric sequence and arithmetic sequence. In this case, you want to deal with a sequence which will only be depending on the previous term. If you come from the first term, the second term depends on the first term. The third term depends on the second term. The fourth term depends on the third term, and so on. That kind of a series or a sequence is what we call recurrence relations. Now, like in this case, we say that recurrence relations help us to find the next term provided the previous term is known. If I have a recurrence relations is like this form, it means that for me to get this, the second term is, the next term is the unknown term n. It depends on the unknown terms n plus 1, meaning 1 is the first term actually. So you're using the first term n is equal to 1 here, plus this one to be able to get the next term. So, for example, if we have this term here, this is the recurrence relations, where the unknown term n plus 1 equals to 2 into n times this, where the first term is 6. So if the first term is 6, if I want to get the second term, I will be able to substitute 2 times 6 here. So because this one here is un when n is 1 is 6. So is the first term, they will take 6, put here, times 2 is 12, plus 3, 15. So the second term is 15. If I want to get the third term, I'll bring here 15, which is actually the second term. So 15 times 2 is 30, plus 3 is 33. So we go on and go on like that to be able to get those terms. A sequence where we get the next term using the previous term is what we call a relations sequence. So if we can categorize recurrence relations into 3 groups. One of them is decreasing sequence, when the next term is smaller than the previous term. The increasing sequence is when the next term is bigger than the previous one. And in the decreasing one, just like we can have a term which is 6, 15, 33. This one you realize that this is our next term. So our next term here is bigger than this one. But if you are to have 15, maybe 6, or 33 here, 33, 15, 6, you realize that in this case, the next term is smaller than the previous term. The next term is smaller than the previous term. So that's what we refer to as decreasing. And the increasing and decreasing are much more easier. Then finally, we have periodic sequence. Periodic sequence actually is a case where the terms repeat. The first term, the second term, then the third term you get another one. Like in this case, you have negative 2, 1, negative 2, 1. So you realize these terms are repeating. If they're repeating in this case after 2 terms, then we say that is a periodic sequence with order 2. Of order 2, you can have when they repeat 3 times. For example, you have negative 1, 2, 0, negative 2, 1, 0, negative 2, 1, 0. That will be a periodic sequence with order 3. So we're going to look at examples of these particular sequences and see how to be able to deal with them. First term is 6. Now we are told to list all the terms of the sequence of this sequence described by this particular function here. So the first thing we need to know is that the first term is 6. So un when n is 1 is 6. So we are going to put here, when n is 1 here, we are going to say the first term, we have said the first term is the same as un. This is the same as u1, which is 6. If you want the second term will be 2. This is the formula for the next term. This is 2 un, when n here is actually 1. Because we are substituting, the previous term is term number 1, so plus 3. That will be 2 times, the first un1 is 6, so 6 times 2 is 12, plus 3 is 15. If we want to get the third term, this term depends on the previous terms. So we are going to have the formula 2, but un here is now 2, because we are breaking the second term here, plus 3, which will be, the second term is 15. So 15 times 2 is 30, plus 3, 33. The fourth term here will be 2 un, but we are using the third term, plus 3. And the third term here is 33. So 33 times 2 is 66 plus 3 is 69. Those are 4 terms. We wanted to get the first 5 terms. So let us see. The fifth term will be now be 2u4, because you're using the fourth term to get the next term. This is 3. It's going to be 69 times 2. 69 times 2 is 138 plus 3. We get 141. So the first 5 terms are here. The first one is 6, 15, 33, 69, 140, 141. So these are going to be the first 5 terms of the relation sequence that we have up here. So you see that actually it's not a big deal to find sequences. The first sequence here is un plus 1 equals un plus 4, comma, u1 equals to 7. So here we have been given the function of the sequence here. We need to get the first 4 terms. We know the first term here. The first term is given to us. The first term is given to us, which is the u1 is equal to 7. So the first term is 7. For us to get the second term, we'll bring 7 here. So the second term here, we are going to get un, where un actually is the first term, plus 4. That will be, the first term is 7 plus 4 here becomes 11. The third term here becomes u2, because we're using the this is our un2. Let me say un1. This will be a u2, so u3. So we plus 4 here. So the second term is 11. 11 plus 4 is 15. And then we go to the fourth term, which actually is here the fourth. So that will be u3, that's the third term, plus 4. This will be, the third term is 15. 15 plus 4. 15 plus 4 is 19. So actually the terms that we are required to give here is 7, 11, 15, 19. These are the first 4 terms of this particular sequence. What about B? But B here you are told the sequence is un plus 1 equals un plus 1 equals un plus 5, where the first term equals to 5. So this is almost similar to what we have done. What we do here is the first term, as usual, the first term here, the first term u1 equals 5. So u2 will be u1 plus 5, which is the same as, this is u1 is 5, 5 plus 5 is actually 10. Let me just say 5 here. So u3 will be, we say u2 plus 5, and u2 plus 5 here is 10. So 10 plus 5 is actually 15. u4 will be u3 plus 5, which is 15 plus 5 is actually 20. So these terms will be 5, the first 4 terms, 5, 10, 15, and 20. So viewers, we realize that getting these particular terms is something that is actually very, very simple. un plus 1 equals un over 2, and that one equals to 10. So that's what we have. Now you realize that for us to get, like we have said, for us to get u1 here is given to us 10. That's the first term. The second term that is u2, will be u1 divided by 2 just like that. So it means that if you have u1 as 10, that will be 10 divided by 2, which is 5. So we can say that u2 equals to 5. What about u3? u3 here will be u2 over 2. So u3 here over 2 here, we know that this will be 5 over 2, which is 2.5. And then u4 will be u3 over 2, which is the same as 2.5 over 2. So 2.5 divided by 2 is 1.25. So we can say that this actually decreasing sequence, which is 10, 5, 2.5, 1.25. So viewers, that is easier. Now what about if you are given a sequence and then you are told to actually get the function for the following sequences? Now the first sequence here is A, 3, 5, 7, 9. Now I want you to know that I will start by identifying the first sequence. So the first sequence, the first term here is 3. So I'll say u1 here is actually 3. If u1 is 3, or a known term, or the term 1 is 3, or the nth term, or the first term here is 3, what about when I want to get 5? From here to 5, what do? We know that for me to get 5 from the previous one, we must have u2 here will always be u1 plus an unknown number here. Probably, let me say that unknown number is x. But we now know that the sum of this will give us 5, meaning that if I have un1, which is actually 3, if you want to get the second term here, we are going to have u2, the second term plus is equal to the first term plus an unknown difference. So we know that if we have the first term is 3 plus the unknown difference x that we have indicated here should give us the second term, which is 5. So in this particular case here, if we want to get x, I will say x equals to 5 minus 3, which will give us 2. So I can actually say that for me to get the second term, I need to get the first term plus, so it means the second term here will be the first term plus 2. So you realize, let us try what will happen if we want to get the third term from the second term. If you want to get the third term from the second term, that is u3, will be u2 plus a known, let's say a known number here is y. We know that if the second term here is 5 plus this y should give us 7, which is the third term. So we'll say that this y will be equal to 7 minus 5, which is 2. So you realize this difference here is 2. So what we can now say that this number, for us to get un plus 1, the next term, it should always be un, the previous term, plus 2. That is what we should, this is the recurrence relationship for this particular, and we know we have to indicate that the first term here should be, the first term should be 3. So this is the recurrence relationship for this particular work here. What about if I give the second one, which is a 20? That's part B. 20, 17, 14, 11. So we have 20, 17, 14, 11. This is decreasing. It means that we will be subtracting something. We know that the first term here is 20. And for us to get the second term here, this is u2, will always be the first term, which is u1, plus an unknown number, in this case let me say x, So if I say a known number, the first term here is 20, plus a known term we don't know here should give us 17. What is happening here? What is happening here is that x here will be 17 minus 20. So x will be negative 3. So what we can say that you can tell that from here, subtract 3 you get this, subtract 3 you get this one. So we can now say that the next term un plus 1 will always be un minus 3. un minus 3, where the first term un is actually 20. So you realize that we cannot solve this problem if you don't have the first term. It will be very unlikely for us to do this. So it means that if I want to get the, let's say this is the fourth term. The fourth term here, what will it be? The fourth term will be un, which is un, which is 14, the previous one. 14 minus 3, which is going to be 20. If I want to get 14 here, I'll say un, and the previous term is 17, minus 3 is going to be 14. So that is what that one is going to give you. Let's look at example 4, which is going to be dealing with periodic recurrence relations. Show that a3, the third term, equals to p power 4 minus p squared minus 2p squared, 2p squared. So we're supposed to show that the first term is that. This thing may look complicated, but it's actually very simple. Remember, you're dealing with such an example is very periodic. We are going to see how it is periodic from here. We are going to see how the relationship occurs for us to know it is periodic. Now, we know that we are told to show that A3 is P power 4 minus 2P squared. We know that for us, the relationship is here. For us to get A, the first term, in this case, they're saying is A1, we know that is P. That is the first term. The second term, which is A2, should be A1 here, squared, minus 1. And that will be, let's say A1 squared here will be if A1 is P, so it's going to be P squared minus 1. Now, P squared minus 1, that is the second term. What about the third term? That is A3. A3 will be A2, that is A2 squared minus 1. And A2 squared here will be P squared minus 1 squared minus 1. So if you have this one, let's open the bracket shortcut. This is P squared will be P power 4 minus 2 times P squared times negative 1 minus 2P squared plus 1, then minus 1. So you realize in this case here, 1 minus 1 is 0, so we'll get P power 4 minus 2P squared. We have been able to show that actually A3 is given by that. The second question in this area is given that A equals to 0, that's part B, given that A2 equals to 0, find the value of P. Find the value of P. So if A2 is equal to 0, where is A2? A2 is here. We know A2 is P squared minus 1. So that one equals 0. So P squared minus 1 equals to 0. So we'll say that this is P plus 1 into P minus 1 equals to 0. So you can say P equals to 1 or P equals to negative 1. But there's something we were told here that P is always less than 0. So if P is less than 0, like we have indicated here, that it means that P can only be equal to negative 1. So we can say that therefore P here equals to negative 1. That's the only answer. And P cannot be positive 1. What about the next question? They said in the next part C, forgive me, let's use this part here. Or let us just clear it so that we can have some space to work with. Part C is asking us to find sigma notation. You remember that we already looked at sigma notation. This is 200, and this is A or R equals to 1. This one is AR. We know AR is actually the number A1, A2, A3, A4, A5. So we want AR. AR from here to 100, meaning probably, let's talk about the 100. You're saying AR like that. What about when that R is 100? So we know that it means, in other words, we want the series of plus. We know that this is summation of. So summation of A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus blah blah until A200. Let us see now. We have known that P is -1. That's what we have seen. P is -1. But P was A1. P was A1. What about A2? A2, we know that A2 was P squared minus 1. If that was A2, let us get what A2 will be. A2 will be 1 squared, -1 squared, which is 1, minus 1 is 0. So A2 is 0. What about A3? A3, we said A3 will be P power 4 minus 2P power 2. Let's see, and our P is -1. So -1 here will be, power 4 will be 1, because raised to an even number, minus 2 into a -1 squared is 1. This will be -1. So realize that this is -1. This is -1, -1, 0, -1. Obviously, it will go to 0, -1, 0, -1. We realized that we talked about this one being what we call periodic recurrence relationship, where the numbers are alternating. And this one is a recurrence relationship of order 2, because only 2 digits are recurring here. So you realize that if we are talking about 100 numbers, meaning that there are going to be 100 negative ones and 100 zeros. So if we add 100 zeros plus 100, because we expect an odd number is here, an even number. So we are going to have, the odd numbers are going to be at the -1, and the zeros are going to be at the even numbers. So we are going to have 100 odd numbers, 100 even numbers, meaning that if we have the summation of this without wasting time, where R equals to 1, AR, I'm going just to get -100. Why? Because 0 times 100 is 0. 100 times -1 is -100. So the summation of this will give me simply -100. That's something that needs you to think. It needs you to think when you reach there. But it's very easy to do it like that if you know in a periodic the numbers will be alternating. So it's not a big deal. What about part D? And part D, the question is asking us to write down the value of, write down the value of A 199. A 199. Now I want you to the position A99. We know we have A1, A2, A3, A4, A5, but they are alternating A1, A2, A3, A4. Now we know that all odd numbers, because it's starting with a negative at the odd number, a negative is A1, A2, 0, A3, -1, A4, 0, A5, -5. 199 here is also a negative. It's also, an odd number. It means that the position of that particular point, the term there is -1. So we can simply say that here A199 here will simply be -1. This is something that do not really require calculation, but it requires simply to think based on what we have here. The ninth term is, being the odd number, must be -1. So that's something actually you can appreciate and be able to think and generate an answer as may be suitable in a question. Thank you, viewers. That will be the end of this particular area of recurrence relations. Please let's move to the next part, which is going to be applications of series and sequences. Thank you.